on our plate today, so I don't want to keep you too long on the Zoom call, but I do want to make sure that you are set up for today. So two announcements first. So first of all, I'm sharing my little quote here. Today is your opportunity to build the tomorrow you want. And I know that sounds, for some people, this would sound a little stressful because you're like, well, I don't know what I want tomorrow. And that's so much work and stuff. But just remember, it's little steps. So get a little bit done. All right. Take a chunk, get it done for all of your classes today. Okay. Make sure that you are, appreciate today because it is an opportunity. And so that's just my little feelings and wanted to share that first. So today is your opportunity to start building what you want tomorrow. Okay. So just remember, it might not seem much, but it is. Every little step counts. Okay. All right. The other big announcement I had to make sure I touch base with you guys on was going to be this. So I'm lied. I have one more announcement after this, but I'm assuming since you guys are all on the Zoom call, you're already okay, but just in case it doesn't start until like tomorrow or something, it should have started yesterday. So I'm not 100% sure. I didn't really understand the email that they sent us, so I'll kind of get a little more clarification. But I will share this image on our updates today. And all that it's showing you is that make sure, so your routine should be that you log into your NISD portal. So that's the first thing. Then you go to your Gmail automatically. So open up your Gmail, leave it open. You got to go to a new tab. So you're going to leave that one open, go back to the portal, click on Zoom. It'll open one more tab. So and now you'll have like kind of like what I have here. So I have my portal. I clicked on my email is on the other screen. Sorry, it's over here. But I have my email open. I have my Zoom open, and then I open my Schoology. And that's kind of the routine that I do anyway. And I'm assuming if you're on a computer, you're probably already doing this. I know it's a little difficult on tablets because sometimes it doesn't always open the new tab. So, but my understanding is you have to have all three of these open to join the Zoom call. So just in case it changes or you end up getting like denied going straight to Schoology, this is the routine. So I will put it in the updates and possibly at the top of our page just so to get us all used to this. For most of us, it's not any different, so don't worry about it. But for some of us, if we've been like last minute, I log into my Zoom call on my phone, I think it's going to start blocking you unless you have all three tabs open. So just FYI, I'm annoyed too. They shouldn't change anymore, but it's okay. It's whatever. It's supposed to keep us safe. All right. The other thing that I wanted to touch base on was obviously that yesterday you did have a nice little survey. I checked this morning and it went all the way up to 94 people have done it. So I'm still waiting on about 50 people. So just make sure that you did do the little Google form from yesterday. So if I open our folders up, so Wednesday was this little Google form. Make sure you do that. I also put it in the updates. I also emailed it to everyone. So just make sure you do take care of that. The exception is if you're a senior, you don't have to do it because you hopefully are graduating, right? So don't worry about it. But everyone else, we still have another year. So we need to pick our science classes, and this is going to help me have a discussion with you. Okay. So make sure that you did do that. So today, I'm going to open up Thursday folder. When you open it up, we have our two objectives right here. So we see that we are going to analyze reactants and products in order to identify those 5 main types. So we've kind of already started that, right? So we've already started looking at what the 5 different types are, right? And I kind of gave you a new way to think of it. And we're going to really look at that new way today because we're going to look at what the situation was at the start, okay? So I'll come back to that in a second. And then we're going to investigate the types of reactions with video clips of demonstrations. So I pulled out everything to try to do the demos again, and they did switch off the gas. I could technically show you the little bubbles and stuff like that, but I felt like it would be a better use of your time to just get your assignment done. So maybe tomorrow I can bring out a couple, but unfortunately they have just like limited us. So it's kind of out of my control, but I did find video clips of everything that I was going to show you. So at least you have that to work with. Okay. I'm sorry. But So I kind of gave this little sentence up here where I said we are recognizing that it's not just random, right? These things are actually happening with the types of reactions. So we have a certain situation with reactants, they have to interact a certain way to give us those products. It's not random. It's going to come from crisscrossing charges. I'm going to show you activity series today, and it's going to matter what you're putting in those the reactants. Okay, it's not just going to be random. Today in your task, you need to be paying attention to, and I put this at the beginning of your assignment, the indications of a chemical reaction. So chemical changes, right? So we had that little list that we had learned at the very, very, very beginning of the year. And so I went ahead and put it here. It's also on your assignment for each of the questions. And then also pay attention to the states of matter that you are seeing in those videos. Okay. So it's like you're here in the classroom. I would be showing you, I'd be saying, this is solid, this is aqueous. Okay. So do your best on it. Your assignment today gives you 3 tries. All right. So for now, our agenda, I said, join us on the Zoom call, and here is the Jamboard. So the Jamboard is open right now. I will reshare that link with you in the chat, just in case you'd like to join me on there or you want to refer to it later. So you can do that, or you can watch your Zoom call screen. Either one is fine with me, okay? So what we've got here is on slide 2. So if you are joining me on the Jamboard, you can go to slide 2. But here, I'm just reminding you that we've got let me pull my tablet up real quick. Okay. Here's a little pointer. Okay, so we have synthesis, decomposition, single replacement, double replacement, and then combustion. So remember, our synthesis, I called it the get together. So it's what I need you guys to pay attention to today is more what's happening at the beginning, right? And you're going to be able to predict kind of what's going to happen at the end. So at the beginning, we see that we have single and single, and then we know that synthesis means that they're going to get together. Then we have the breakup. That means that you're starting with something that's already together, just one thing. The only option it has is to break apart, okay? And it can either stay as it is, or it can just break apart. So most likely, decomposition, you're always going to have just one combination thing on the reactant side. The Steal Your Girl one is your single replacement, and that is the one where we're going to have something comes in and bumps out that first guy or the second guy. Right? So I will show you where that comes from on this next slide. The double date gone wrong. Remember, okay, so Steal Your Girl is you have one single thing and you have one together thing. The double date gone wrong means you have 2 double things, right? And then what they do is they end up just switching partners, right? So we saw that the metals might switch spots, okay? And then finally, this combustion. All right, so pay attention to this. On the combustion, you will always have some sort of a fuel. Fuels are carbons and hydrogens together. They will always combust in oxygen. So if you look at this, it looks very similar to a Steal Your Girl one. It is not the same because it has that carbon hydrogen and this oxygen right here. Okay? So what you're going to need for your assignment today is knowing what the products are. And that's always going to be, pay attention, carbon dioxide and water. Carbon dioxide and water. So again, if you're on the Jamboard, make sure we're going to switch over to slide 3. Okay. And also pay attention on your assignment today, gas and gas. You're going to have to put in those states of matter. So know that those are gases. Okay. All right. Hold on. I'm letting someone in real quick. Let's make sure you got in. Maybe. He's in. All right, cool. Welcome. Good morning. Okay. So once again, you have this on slide 2. All right. So slide 3. So if you're following along on the Jamboard, go to slide 3. Okay. So what we've got here is we have all of these things. And I'm sorry that they're a little blurry. I took a snip and it expanded it and it made it blurry. But what we've got here is I am only giving you the reactants. All right. Now, good news is I'm not going to expect you to write me the products. However, I would like you to just look at the reactants, what's going on, and we should be able to pick out which of these it is. Okay. And then I'll kind of write the products for 1 or 2 of them and we'll figure it out. Okay. So for this first one, very, very first one, we're going to start with the hard one. This one, we have carbons and hydrogens together with an oxygen. Carbons and hydrogens together with an oxygen. Any idea of what this one might be? Hint, it looks like single replacement, but it is not. It is the other one. So if you have an idea, you can type it into the chat or you can unmute your mic and say it. But what do you guys think? We have a fuel and an oxygen. So I'm going to switch the slide back to 2 for my people watching the Zoom screen. So you have a fuel and some oxygen, right? It's not the same as this. Fuel and oxygen. So we have, okay, I got a private chat. Good. So it is combustion. This is combustion, right? Okay, so we're going to go ahead and I'm going to grab that word and we are going to throw this into our table. Okay, so we have combustion. So next question is, what are those products? What are they always going to be? So combustion means that we took this fuel, we had a room full of oxygen, gave it a little spark, and it caught on fire, right? So fire, your products are always going to be, okay, when think of what is given off in a fire. What kind of gas? It's so silent. I hope you guys are paying attention. All right, I'm going to help you guys out. Always, you need this for one of your questions today. This is the one product that I will always ask you about. It is always going to be gaseous carbon dioxide, gaseous water, meaning water vapor and carbon dioxide gas, okay? So those are always going to be the products with a combustion reaction. So when you get to that question today, that's the answer choice that you want to pick, okay? All right. So the next one we've got is we have a single thing and a together thing. A single thing and a together thing. So I'm going to go back to the previous slide, so slide 2 to kind of refer to that. So which of these, so this is single, this is a together thing, this is a single and a together thing. This is the Steal Your Girl one. So we're going to go back to that one. So Steal Your Girl is known as our single replacement. So I'm going to move that into our table. So single replacement, right? And so what we're looking at is that zinc is trying to kick somebody out, okay? So what I'm going to actually take a second to refer to is I wanted to show you, because it's kind of neat, okay? I wanted to show you this little activity series. And so what I want you to see on this is that we have zinc, hydrogen, chlorine. So looking on this list right here, hopefully you can see, so we have a whole bunch of metals up here, right? And there's zinc. So we have zinc here, and we're going to keep looking down our list to see if hydrogen or chlorine are there. There's hydrogen. All right, so the way that a single replace, so remember, it's Steal Your Girl, right? You can't steal somebody else's girl unless you're better than the one that's already with that girl, right? Or boy or whatever, okay? You got to be better than the one that you're kicking out, right? Well, look at zinc. Zinc's way up here. Hydrogen is way down here. Zinc comes in and bumps out hydrogen. That's what we use the activity series for. For these single replacement reactions, we want to know, is it possible? Is it going to happen? Right? And we want to know, okay, if it does, who is it kicking out? So in this one, we do see that zinc was higher up than hydrogen. So zinc is going to kick out this hydrogen, and we're going to be left with zinc chloride plus hydrogen gas. So we're going to release some hydrogen gas. So you're going to see this one today on your little investigation. All right, let's finish this up quickly. So the next one, we have a together thing and another together thing. So that's your double date gone wrong or your double replacement. Okay. And in solutions, we're going to learn how to do those products. We're not going to learn it in this chapter. All right. This one we have something that is all together, and that's it. What is the only option you have if you already have stuff pushed together? The only option it has is to break apart, right? So this is going to be your decomposition. This next one down here, we have a single thing and another single thing. So those guys are going to combine in synthesis. This is the get together, right? So I wanted to show you real quick, when you have a get together, this is where that crisscrossing charges thing is going to matter. So potassium has a +1 charge from our periodic table. I am so sorry for my scribble. I thought I had this. Okay. And then your sulfur has a -2 charge. we crisscross those, we end up with K2S. All right, so this is synthesis. Then our last one here, we have a single thing and another together thing. So that is going to be another example of single replacement. Okay, so you have this to refer to while you're doing your little lesson today. I did want to touch base on you will have to balance one example today. So for this, I'm going to choose the most difficult one, which was this, to remind you how to do your box method. And then we should be done. Okay, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to put that all in a box. So there's my fuel. I have 2 oxygens, put them into a box. I'm going to go across. I have carbon with 2 oxygens. So I'm going to put them into a box. And then I'm going to have my 2 hydrogens with oxygen, right? So from here, we can kind of see, well, carbons are definitely not balanced and hydrogens are definitely not balanced. And then the oxygen, since it's split up, we'll deal with that one last, okay? So hydrogens, let's handle that one first. So I see that I need 8. So that means that I need to add in more waters in order to have 8 hydrogens. So notice, I'm not just putting hydrogens, you're putting the whole thing. So now that I have those, I have my 8 hydrogens. I still only have 1 carbon, so I'm going to handle my carbon. So 1, 2, 3. I'm going to go ahead and add in. If I know that I need that, remember each one of these, I totally messed that one up. Sorry, we don't need this last one. All right. So each one of these has 2 oxygens attached to it, right? So we have that. So we have our 3 carbons. We have our 8 hydrogens, 8 hydrogen, 3 carbons. Now we got to count up our oxygens. So for oxygen, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Only 2 over here. So what can I multiply by 2 in order to get 10? Private chat. Good. Okay, 5. Good. So we have 1, 2. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So final step in this balancing is we count up our boxes. So I have 1. So I put a 1 in front of that first one. 1, 2, 3, 4, 5 in front of that second one. 1, 2, 3 in front of that third one. 1, 2, 3, 4 in front of that last one. Okay. So don't forget your balancing. You do have one question that has the balancing on it. All right. The last thing I'm going to show you is just your indicators of a chemical reaction. So don't forget, what are the signs? We are looking for bubbles. Oops, sorry. We're looking for bubbles, right? So anytime you open a soda, that is actually a chemical reaction. You're releasing carbon dioxide. It was a carbonic acid. Soda is carbonic acid. So way cool, right? All right. A change in color. It's not always going to be this pretty. Okay. But changes in color, if you're on the Jamboard, we're on slide 5, by the way. Changes in colors are not always going to be this pretty. It could be me putting something into the flame and it burning, right? And turning black. So that could be a change in color. A change in temperature. All right. So we could put a thermometer into a reaction. You're not going to see that one today, but we could put it in there. And if it raises the temperature, that means that it released heat into that thermometer. If it lowered that temperature, it's absorbing heat from that thermometer. When we get to thermochemistry, we'll kind of go into that a little bit more. Precipitate, you'll see this one today, okay? So anything that looks milky after you pour 2 clear liquids together is going to be a precipitate. It's a solid that is forming. Okay, and I wanted to show you this other picture because it looks like muddy water. So remember, precipitate is not me putting dirt into water and making muddy water. It is the fact that I poured 2 clear liquids into a container and it formed the muddy water. That's a precipitate, okay? So today's you're going to see a cool yellow one. It's my favorite. It's one I always do in here. All right, and then finally, a light is produced. So if you guys remember on Halloween, if you were in person, I tried to show you that these lit up. And so we have 2 clear liquids and they formed light, right? Anything that gives off light energy is a chemical reaction. Okay, so any fires, that's light. So keep that in mind when you see these couple demonstrations. You won't see new odor or explosion today. You'll see one explosion, but you don't have to answer that question. All right, so that should help you get started on your assignment. When you open it up, the first few are kind of like, hey, do you know how to do this? So if you are struggling on the first couple, there's some of the stuff from today. when you open it up, so this first one, you should be able to just look at these and answer the question. Do process of elimination for this last one. The very last one is a neutralization, okay? It's not one that I'm going to hold you guys accountable for. I just forgot to take it off. So question number 2, you can look at these and answer, or push play on the video and it literally will give you the answer. So you can kind of already see he talks about this one, which is synthesis, okay? But look at these: single, together, together, single, right? So make sure you're just answering that one the best you can. This one is one where you're going to have to balance. So looking at this, I made it easy ones so that you might be able to just look at it. So notice that you have 2 over here, only 1 over here. So when you change one of those, just make sure you do that. And then you're going to put in your types of reactions over here on the left-hand side. When you get to question 5 through 10, those are the actual demonstrations. So you can look at the reaction and answer what type it is, or you can just watch it and then do all the answering the questions. But you're going to be picking your states of matter, okay? All right, so if you need help, please, please, please don't hesitate to reach out. I will leave the Zoom call open for a little bit. If you need to stay on for any tutoring, let me know. And I will see you guys tomorrow. We're going to review all this tomorrow, okay? So do your best on the assignment. I gave you 3 tries on it. If it's not